Hi, my name is Nadiya Lobanova, and today I'm going to tell about filtration and glomerular filtration rate. Process of filtration is the first stage of urine production, and it takes place in the renal corpuscle. Here is the renal corpuscle. It consists of two structures, glomerular capillaries or glomerulus and Bowman's capsule. Glomerulus receives its blood supply from afferent arteriole of the renal circulation, which diverges into the capillaries of the glomerulus, and drains into efferent arteriole, which forms from the convergence of the capillaries of the glomerulus. These arterioles consist of smooth muscle. The constriction of the afferent arteriole decreases both blood flow and filtration pressure, whereas constricting the efferent arteriole decreases blood flow but increases filtration pressure. So now the glomerulus has the special endothelial cells, which are fenestrated and have negatively charged surface that repels many plasma proteins. The fenestra are the large diameter pores which go from one side of the membrane to the other side of the membrane. These pores are relatively large to allow free filtration of fluid, but not large enough for the red blood cells to be filtered. Now let's talk about the Bowman's capsule. It has two layers, which are visceral epithelium and capsular epithelium. These layers separated by the capsular space. The capsular layer is a single layer of simple squamous epithelium and does not function in filtration. Visceral layer is overlying the capillaries and composed of large cells podocytes. These cells have long processes called pedicles, which wrap around the glomerular capillaries. These pedicles fit together very tightly and overlap each other, but they still have narrow gaps between them. They are filtration slits. Size of these filtration slits restricts the passage of the large molecules and cells into the capsular space. Podocytes cooperate with mesangial cells to support the structure and function of the glomerulus. By having the actin-like filaments inside, mesangial cells are able to contract, and in this way they control the capillary diameter and the rate of capillary blood flow. Together, podocytes, endothelial cells of the glomerulus, and the glomerular basement membrane form a filtration barrier, so plasma inside the capillaries is selectively filtered through this barrier. Now when we know the structure of the renal corpuscle, let's go back to the filtration. In this process, blood is flowing in through the efferent arteriole into the glomerular capillaries, where blood pressure pushes water and dissolved solutes out of the capillaries through the filtration barrier into the capsular space, and then it goes to the renal tubule. This protein-free solution is known as filtrate and similar to blood plasma. The rest of the blood continues its way to the efferent arterioles. Several pressures control the glomerular filtration. They are glomerular hydrostatic pressure, blood colloid osmotic pressure, and net filtration pressure. Glomerular hydrostatic pressure is the blood pressure in the glomerular capillaries. This pressure tends to push water and solute molecules out of the plasma and into the filtrate. Blood colloid osmotic pressure tends to draw water out of the filtrate and into the plasma. It thus opposes filtration. Net filtration pressure is the net pressure acting across the glomerular capillaries. It represents the sum of the hydrostatic pressures and the colloid osmotic pressures. Last thing I am going to talk about is the glomerular filtration rate. It is the amount of filtrate that kidneys produce each minute. GFR averages an astounding 125 ml per minute. In other words, that means roughly 10% of the fluid delivered to the kidneys by the renal arteries leaves the bloodstream and enters the capsular space. Also, GFR depends on the net filtration pressure across glomerular capillaries, so any changes in net filtration pressure affect the glomerular filtration rate and kidneys function. Thank you for watching my video about filtration and glomerular filtration rate.